Hi everyone, this lesson is for geometry students. This is chapter 3, day 2. We are going to be covering ratios and similarity and a few application problems. So let's get started. We're going to do a little warm-up dilation and something that we did last week. We have a scale factor dilation of -2.5. So what I'd like you to do is to start off writing all the points down. So we have point A, which is going to be 2, 6. We have point B, which is 1, -1, and we have point C, which is -3 and 0. And by a scale factor, that is, enlarging it or shrinking it, but the negative by 2.5, we are then going to end up with an A prime. And so what I'd like you to do is, using your calculator, or just multiply by hand, go 2.5 and then times 2, and that's going to give me -5. And then we have 6 times -2.5, and I get -15. Then we have point B, so for B prime, and you're just multiplying this by the -2.5 by every one of your values, your coordinates. So you have 1 times that is going to give me -2.5, and then -1 times that is going to give me +2.5. For C prime, I'm going to get -3 times -2.5, and that's going to be 7.5, and then 0 times -2.5 is just 0. So we are going to plot these new points, and in plotting these new points, we have -5 and then -15 way down here. That's A prime. Then we have B, which is -2.5 and then +2.5, so that's B prime. And then you have C prime, which is 7.5, 0, which is right here, C prime. And so what we have now is this graph that looks like this. And not only is this an enlargement, but if you notice that this has been reflected, rotated, what has it done? So see that negative sign out front? Definitely has affected it. How did it affect it? Did it flip it over and over? See, if I took this, my A value, and I reflected that, over, let's say, y equals x or something like that, right? It'd be flipping over. But also, how would the C get up? So what I wanted you to do is discuss in your groups, like how that would happen. What is the negative sign? What kind of an effect does it have on my graph? So we'll be talking about that later. Learning targets today are, we're going to be talking about ratio perimeters. We're going to be talking about similarity, making proportions. There's also a really cool Khan Academy video on dilations that I think you should watch, and I put that link on your slate as well. So we're going to start up just practicing some additional proportions so that we can multiply and do that. We're going to cross multiply. If you have one term on the left and one term on the right, which we do, then you can cross multiply. So I can say 3 times x, which is 3x, is equal to 2 times x plus 5. We get 3x equals 2x plus 10. I'm going to subtract 2x, and I'm going to get just x is equal to 10. Now, remember, I'm solving this, so my answer should be in a solution set. Additionally, last week, we also talked about restrictions on what the values of my denominator would not be able to equal. So, for example, what value would this not be able to equal? So we know that also x could not equal -5, because if x equaled -5, if x equaled -5, so x cannot equal -5, because if it did, then that would make that denominator equal to 0, and you can't have that denominator equal to 0, or you would have undefined equation. So let me just finish rewriting this. Okay. All right, cross multiplying again. We have x times x plus 8 is equal to this quantity here. I'm going to move this over just a little bit so I have some room. And I'm going to get this times that. So I'm going to go x plus 4 times the quantity x plus 1. And in doing that, I'm going to distribute, right? So on the left side, I get x squared plus 8x. And on the right side, I'm going to distribute that. So x times, or FOIL, and x times x is x squared. And that's plus x plus 4x and then plus 4. And, combining like terms and whatnot, solving for x, I do want to isolate the x. So I do want the x's on one side and my just regular numbers onto the other side. So let's get our x's together. If I were to subtract x squared from both sides, actually these would go away and they would be, eliminated. So the next thing I have is I have 5x on the right and 8x on the left. So I'm going to subtract 5x from both sides. And in doing that, I get on the left 3x. And on the right, it looks like I just have 4. So that means x is equal to 4 divided by 3, and that's my solution to this problem. Note that, again, when I'm looking at this equation, I do have some restrictions for x, and for this part right here, x would definitely not be able to equal -4, and for this part of the equation, x would not be equal to -8. So those are my restrictions because, again, you can't have a 0 on the denominator. For this problem here, we have a quadrilateral, any four-sided shape. And in this four-sided shape, we're trying to find the measure of the smallest angles. So what you need to understand is that each one of these ratios is in the form of 6 of some value that I don't know. I don't know all of the values, but I know that this is a ratio of 6 of that, 7 of that, 8 of that I don't know, and 9 of that I don't know. Additionally, I do know that all the values of my angles, which this represents, then, and as they're talking about the angles, that the sum of the angles of any quadrilateral is 360 degrees. So if I add up all of my angles, so it looks like I'm going to have 6x plus 7x plus 8x plus 9x. So all you have to do is add 6 plus 7 plus 8 plus 9. I got 30 x's is equal to 360. And I'm going to take 360 and I'm going to divide that by 33, 12. I get 12. So I get, dividing this by 30 on both sides, 3 divides into 36 12 times. So x is equal to 12. And that's not my answer. That's just what x equals. My answer is asking me for the smallest angle. So I have to plug 12 back into each of these x's and just see what angles. And of course, 6 times 12 is going to give me my smallest angle. So therefore, so you would write like this. These 3 dots mean therefore. And so you would just say, let's see, therefore, the smallest angle is 6 times 12, which is 72 degrees. So again, our learning targets, our ratio of our perimeters, and just also solving similar figures, and just really want to stress the proportionality in how to write a similar statement. So we're going to work on that. So for ratios, we're going to talk about what a scale factor is and what a ratio is. So a ratio is a comparison of 2 quantities. It's something to something else. The ratio can be written 3 ways. You write it as A to B like this, or A to B, as in like say it like A to B. So what we have here is a comparison of 2 similar shapes. We have the original and we have an enlargement. It's like a dilation, right? And so what I want to know is what's my scale factor. And you're going to write your scale factor as a ratio of those 2 numbers. So you're going to compare the sides. So I don't know what this side, the tall side, the height, I don't have the base, but I do have my hypotenuse. It looks like the hypotenuse, because it's a right, triangle. And so what you guys have here is you've got 6 to 10. So 6 over 10 is going to reduce down to 3 over 5. So that's my ratio of the 2 values. So don't forget that when you write this as a ratio like this with 3 to 5, that you can also write it as 3 to 5 like this, or you can write it as 3 dot 5. And so that would be the scale factor, and this would be the scale factor from small to large. The next problem here, to find the ratio of the scale factor, looks like large to small. So remember, you're going to put a larger value to the smaller value. So that would be 8 to 4. And that scale factor, if I reduce 8 to 4 by 4, that would be 2 to 1. And so my scale factor, if I was asked what my scale factor is, it's 2 to 1. So what that does for me is, for example, I'm trying to find this side like this. I don't know what that side is. So I know that if I make a proportion, which is the two ratios set equal to each other, I can say 10 is to x. So I could say left side is to left side. I could say 10 is to x as 8 is to 4, or we already reduced that as 2 is to 1. And then I would just cross multiply. I get 2 times x, which is 2x, is equal to 10. So then divide by 2, x is equal to 5. Okay. Additionally, you also could just have used like 14 is to 7 to get the scale factor, because what I'm looking at is I have to be able to have two sides. Meaning I've got 14 is to 7. So if I had compared those two sides instead, I still would have reduced those values to 2 to 1. So that's completely fine. Now, in this problem, I am trying to find another one of the sides. Let's see. I am trying to find, first I'm going to find this side here. And in finding this side right here, I'm going to go x is to 27 as 1 is to 3. And in cross multiplying that, I'm going to get 3x equals 27. Divide by 3, I get x equals 9. And so that means this side right here is 9. And so basically, just given a scale factor from one to the other, you're always going to want to be able to go either small to large or large to small. If they say, A to B, they're looking for small to large. Okay. Using the ratios of similarity, we want to also know whether or not these two shapes are similar. Now, they look like they have the same shape, but are they actually similar? So you would go like this. 2 is to 7. So I could go, these are my options. I can go left side is to left side. I could do that. 2 is to 7 as this base is to base. So I could go 6 is to 21. And in multiplying, to check to see if these two rectangles are similar, if I cross multiply and I go, okay, well, 7 times 6, does that equal 2 times 21? So we have 42 equals 42. So yes, because they equal each other, that means my ratios are congruent, are equal. That means that the two shapes are similar. The two shapes aren't congruent. Obviously, they have different lengths, but they are similar. And remember, what similar shapes allow you to have is congruent angles. The angles stay the same, but the sides aren't. Just a note, there's another ratio you could have used. You could have just said, instead of going height is to height, you could have also said, well, 2 is to 6 as 7 is to 21. And again, cross multiply, I get 42 equals 42. The difference is, and I want to make sure I'm very clear about this, if I were to ask you what the scale factor was, though, I cannot compare two sides of the same shape. Okay? You're going to want to, the scale factor is one side to the next side. You're not going to say, it's one side to the next. So just be very careful on that. We know that these are similar, but we didn't ask for the actual scale factor. And when you're looking for the scale factor, you're comparing two sides. You're comparing a side over here with another side of the other shape. And it's got to be a corresponding shape. So like 2 to 7 would be my scale factor. I would go 2 is to 7. That's my scale factor. Or I could say 6 is to 21. This side is to this side, as long as it's not 2 is to 6, because that's not my scale factor. If I were to reduce 6 over 21 by 3, I'd get also 2 over 7. For this problem here, this is like the famous tree problem. We've got a shadow of a tree. This is the shadow of the tree right here, okay? And what they're saying is you've got some person over here, and you're trying to find either their height or the tree's height. There's a lot of videos online where you can watch the tree shadow, the famous tree shadow proportion problem. But what's most important is that you know this. You've got this person and you've got this tree, okay? And you've got two triangles. And the two triangles are this little triangle right here, which is this one here. And then you've got the larger triangle that looks like this, all right? And then what's happening is basically this triangle here actually fits in here. But we're going to separate those because we want to make a proportion, all right? And in doing that, let's see. We know that this distance here is 5. So we know that this little distance is 5. We know that these are both right triangles. And we know the height. We don't know the height. That's what we're trying to find. We know the height of the kid is 4. And we do know this whole length, which is 125. And remember, in order to find x, or the height of the tree, we're trying to make a proportion where we're comparing two ratios. So we're going to go, and you have options for sure. You can either go 4:x as 5 is to 125, or you can say 4:5 as x is to 125. So either way, see, if I go 4:5 as, so I go height is to base as height, which is x, is to base 125. So we're going to go 5x equals 125. Whoops. 125 times 4, right? That's going to be just 500. And then we're going to divide by 5. I get x equals 100. So that means that the height of this tree is 100. And that was creating two ratios. Like we had 4:5 as x is to 125. But note, if I'd ask you for the scale factor again, you need to understand that the scale factor does not compare the same sides of a triangle. It compares one side with another side. So I can say my scale factor is either 4 to 100, which would make it 1 to 25, or I could say it's 5 to 125, which is still 1 to 25, 1 to 25. So we have the properties of our proportions. We call it pop. Given a ratio, there's different ways you can actually write this. Most importantly, these are like the basic ones where we say A times D is equal to B times C. But there's a couple of other ways that you could write it. You could write it like this, where you could say A is to C this way. You could say, going across, A is to C as B is to D, like that. See that? That's that one, where you're going across and setting those equal to each other. Or this one where you flip them upside down, right? You've got A is to B, or B is to A, as C is to D. Now the last one, which is most important and very difficult, is that you're adding the two A plus B over B, and then that's equal to C plus D over D. So let's just like an example of this, because it's a little bit, far out a stretch here, is if I said 2:3 as, and then I were to say, let's say that's going to equal 4:6, right? If I multiply by 2 on both. Okay, so this is my ratio. So if just the first part, if I went 2 times 6, that equals 3 times 4. That's this one, okay? The second one is saying 2 over 4 is equal to 3 over 6. If I still cross multiply, I get 2 times 6 equals 3 times 4 again. This one is saying B over A, so it's flipped it upside down. So it's saying 3 over 2 equals 6 over 4, and I still get 12 equals 12. And lastly, for this one, A plus B over B, that's saying 2 plus 3, which is 5, over 3B, is equal to 4 plus 6, which is 10, over 6. And again, if I were to cross multiply, I'd get 30 equals 30. Even though these are the same values, they're different values than the 12 and the 12, obviously, because I changed the problem because it was a sum. I still get the equal values because it is a proportion. And then this is just, again, telling you, just based on making an equation. So I could say left side, A is to C as B is to D, okay? And then my scale factor would be A to C, or it would be C to A, depending on if I'm going, and they'll give you directions on whether you're going large to small or small to large. So we have two triangles. It says assume one triangle, so we're just going to make it a triangle, is 6, 7, and 10. And I'm going to create these corresponding. And then we've got a 3, and then a 4, and then a 5. And then what your job is to do is to decide whether or not these two triangles are similar. Now, if these two triangles are similar, they are similar if the sides are proportional. That's how you know if they're similar. So we're going to go 6 is to 3. So I'm just going to choose two sides. 6 is to 3 as 7 is to 4. So 7 is to 4. Cross multiply, I get 6 times 4, which is 24. 3 times 7 is 21. Right off the bat, these do not equal. So if they are not equal, therefore they are not proportional. And if they're not proportional, that means that the angles are not congruent and they are not similar. So therefore, these are not similar. Now, sometimes, when you could test it again, if you're not sure, you can go 10 is to 5, right? Right side is to right side. 10 is to 5 as 7 is to 4. And I've cross multiply again, I get 40 does not equal 35. So therefore, they are not proportional. And they're not, if they're not proportional, they're not similar. So in this problem, though, they're not asking me whether or not they're similar. In this problem, they're saying these are similar. Therefore, they're proportional. The sides are proportional. So find the values of x and y. So number one, I would ask you what the scale factor is on a test. I'm going to ask you compare the sides. So you can't go 11 to x because I don't have x. You can't go y is to 18 because I don't have y. But I could go small to large, 8 is to 24, which means my scale factor is going to be 1 to 3. So I am going to ask you what my scale factor is. Secondly, I'm going to ask you what x and y is. So in order to find x, which is this tall value here, I'm going to compare it to that similar corresponding value. So I'm going to go 11 is to x as, now this is where I would use my scale factor. I could go 8 is to 24, but I've already done that and said, well, I don't want to write 8 is to 24 because that's going to give me a larger number than I need to deal with because I've already reduced it. So now I'm just going to use is 1 is to 3. So I'm going to cross multiply x equals 1 times x is x, 3 times 11 is 33. So I know x is equal to 33. So this tall side is 33, okay? Then the next thing I'm going to ask you is to find y. And in order to find y, I'm going to say, well, y is to 18 as scale factor. 1 is to 3. So 3 times y, I'm going to cross multiply. 3 times y equals 1 times 18, which is 18. So y is equal to 6. And then I'm done. So for these, we're going to solve for x again. And it's telling me, again, it's not asking me to figure out if they are or aren't similar. It's telling me, hey, these are similar, and let's find x. So we're going to compare these. So I'm going to go 2 is to 6. So 2 is to 6 as 4 is to x. I went 2 is to base, height is to base as height is to base. That's what I did. So 2 is to 6 as 4 is to x. So I'm going to cross multiply. I get 2x equals 24, but x is equal to 12. Now, just a note, I am going to ask you for the scale factor again, and the scale factor is not 2 over 6. The scale factor, again, compares one side of one shape to the other corresponding side of the other shape. So it would be, the scale factor would be 2 is to 4 or 1 is to 2. That's what it would be. For this problem here, this actually has been flipped. And so be very careful. And a lot of people will just like rewrite this to make it easier to see. So this is 3. This tall part is 6. And so now I can make my proportion and draw it out, right? I can say 4 is to 3. So I can go 4 is to 3 as this side, but be careful because if I start with large, it's got to go large is to small. So then it's going to go x is to 6. cross multiply, I get, let me erase this now. I get 4x, no, I get 3x, 3 times x. 3x is equal to 4 times 6, which is 24. Divide both sides by 3, and I get x equals 8. Okay, put that in solution set. Lastly, here's this thing. I'm given a perimeter of 60, which means this is also 21, right? And what's 60? Because if this is a rectangle, then opposite sides are congruent, but not that side. That's opposite with that. And so basically for this problem, here I'm going to make this a little bit larger. For this problem, in order to find the values here, I know this is 21 because that's congruent to that. I know this is equal to this, but we don't know what those values are. But I do know that whatever this value is, there's 2 of those. So I'm going to just call it A, okay, for right now. So I've got 2A plus 42 is equal to 60. I'm going to subtract 42 from 60. So 60 minus 42 is 18. So I know that 2A is equal to 18. That means A is equal to 9. So that means that these sides over here are 9. And so that's 9, and then that's 9. And so therefore that I can go 3 is to 9. So I can say 3 is to 9. So this height is to this height. So 3 is to 9 as x is to 21. Top is to top. So x is to 21. It's light in here now. And so therefore, I'm going to cross multiply. I get 9x equals 3 times 21. I'm going to divide both sides by 9. And then I get x equals, let's see, 9 can be broken down to 3 times 3. And I'm just going to go, well, this 3, I'm going to cancel into this 21 and get 7. This 3, I'm going to cancel into that 3 and just get 1. 1 times 7 is 7. So that means that x is 7. So this side here is 7. So just a note, let's look at the perimeters for a second. 60 here. What's the perimeter for this? Let's see. 7 and 7 is 14. 3 and 3 is 6. 14 and 6 is 20. So my perimeter for this shape is 20. And my perimeter for this shape is 60. And what I want to, the reason why I'm looking at that is because I want to know, I wonder what my ratio of perimeters is. So my ratio of perimeters is 20 to 60, which is 2 to 6, which is 1 to 3. Now let's think about this. If my ratio of perimeters is 20 to 60 or 1 to 3, that, looking at my scale factor, which is 3 to 9, which is 1 to 3, it definitely looks like my scale factor, which is 1/3, is the same thing as the ratio of my perimeters. Okay, so those are actually equal. So that's a thing to know. So great segue into this problem. The ratio of perimeters is the same value as your scale factor. Okay, and so whatever your scale factor is, that's the ratio of your perimeter. So let's think about that in a minute. First, let's compare our 2 sides and find the scale factor. So we've got 2 is to 4. So small to large, 2 is to 4. And that's going to be 1/2. So I know my scale factor is 1/2. Let's find f. In order to find f, I'm going to go 7 is to f as 2 is to 4, which is 1 is to 2. Cross multiply, I get f equals 14. So I know that f right here is 14. And then in order to find a, I'm going to go a is to 10, right side is to right side, as my scale factor, 2 is to 4, which is 1 is to 2. Again, cross multiply, 2a is equal to 10, so that means a equals 5, so this value is 5. Now the perimeter of this left-sided shape is 5 plus 2, which is 7, plus 7, which is 14. So the perimeter of the left triangle is 14. The perimeter of the right triangle, We have 4 plus 14, which is 18. 18 plus 10 is 28. So this perimeter is 28. So if I were to compare my two perimeters, I've got the perimeter of my small, right? My small triangle over the perimeter of my large triangle. I've got 14 over 28, which is 1/2, which we knew because of the last problem, which was our scale factor. The ratio of areas is a little bit different because we know that the ratio of the perimeters is equal to our scale factor, right? And so thinking about that, let's look at these problems. We have two similar triangles, okay? I know that they're similar because their angles are congruent. See, remember, similar shapes have congruent angles. And so in doing this, we know that we can go 3:6. Now that's my scale factor. If you notice, one side compared to the other side. So my scale factor for this problem is 1/2. 3:6, which is 1/2. So in order to find x, I'm going to go 5:x as 1:2. I'm going to cross multiply. I get x equals 10. So we have x. Now we have to find a. And a is going to be a:8. So a:8 as, let's see, 1:2. My scale factor, cross multiply, 2a equals 8. A is equal to 4. So we have x is 10 and we have a is 4. Now, what is the ratio of areas for the two shapes? Now, thinking about area for these triangles, once we found what all these values are, okay, so I'm going to erase this because we now know what our values are. We know that x was 10, so this is 10 here. We know that a is 4. And if you remember what area is for a small triangle or for the triangle, area equals 1/2 the base times the height, but the base has to be perpendicular to the height. So therefore, if it's 1/2, so it's for the first triangle, for the area of this small triangle, that's going to be 1/2 3 times 4, okay? So 12 divided by 2 is 6. And then for the area of the larger triangle, that's going to be, again, 1/2 base times height, so 8 times 6. So that's what? 48. 2 goes into 8 4 times. 4 times 6 is equal to 24. So that means that, how does this relate? So we know that the ratio of the areas in this problem is 6/24, which actually is 1/4. Now, how does that relate to the ratio of perimeters? And what you should figure out is this, is that we know that the scale factor is a value 1/2. We know that the ratio of the perimeter is also equal to the scale factor. And if you don't believe me, add the values up. We've got 5 plus 3 plus 4. That's what? 7 plus 5 is 12. To the perimeter of this, which is 18 plus 6. What's 18 plus 6? That's 24. And that's going to be 1/2. And therefore, the ratio of areas is actually taking my ratio of perimeters or my scale factor and squaring that, and I get 1/4, which is what we got up on top. Right on. Okay, so next we are going to write the following ratios in simplest form. Basically, they are asking for something very specific. They want first, this is part 1 and this is part 2. First, they want the ratio of the smallest angle to the largest angle. So in order to do that, I actually need to know what my smallest angle is. So I'm going to go, what's 180, because I know that's the sum of all three angles, minus 91 minus 26, and I think that's 63. Okay, so we know that this angle down here is 63. Additionally, we should also know that the smallest angle is opposite the smallest side. And the largest angle is opposite the largest side. So this is basically my smallest side, and this is my largest side. So they want the smallest angle. So the smallest angle is 26 to the largest angle, which is 91. And so this is just the ratio that they want. Don't make that into a decimal. The other one, they want, what is the ratio of BC? So BC to the perimeter of triangle ABC. So BC is this value here, so that's 27. And to the perimeter, we're going to have to add 12 plus 24. So hold on. 12 plus 24 plus 27. So we go, let's see, what is that? 12 plus 24 plus 27 is 63. And so you have 27 over 63. And what I would suggest that you do, it's, you could divide it and get a decimal, but I don't want a decimal. I want a fraction. So I would just divide. I think for me, I would divide by 9. And so in dividing by 9, 27 divided by 9 and 63 divided by 9, that's going to give me 3 over 7. And then that right there is that ratio. That's not my scale factor. You only have a scale factor if you're comparing two shapes. So we have no scale factor. So for this problem here, they're asking me what makes this statement true. And it looks also like this side here is similar to the, they're comparable to that side. So it looks like I might have to redraw this shape just to make it look correct. So like this would still be T, but these values would be different. That would be C, and this over here would be A. A would be my shorter side. So that would be 10. This would be 16, and this value here would be 18. So now what makes sense? So if they're going DOG, and they're going like this, D, O, and then G. So that's DOG. You would say triangle DOG is similar to triangle. You have to start in the same place. C, T, A. So it'd be C, T, A. Now, that would be, looks like this value right here. So you just got to be careful what they're doing, because if I went this way for the DGOs, if they went D, G, and then O, I would have to go C, A, and T. And that means this one also is true. And then I'm looking over here. If I went O, G, D, so starting with O, then I would have to start up at the top, which they didn't. So this is an out, and then that's an out. So finding the value of the variable in this similar figure, it looks like this is what we're trying to find. So we would say 6 is to x as 12 is to 9. Is that right? I don't think so, because look at my two shapes. It looks like one shape is twisted, is turned on its side. So one of the main things that you guys have to remember is this. You have got to make sure that your two shapes are facing the same way, same direction, and all that. So what we have is this right here. Okay, and so if I know that I look at this right here, and that's telling me how to write it. So this is going to be A, B, C, D. See how they did that? They went starting here, A. So if I'm starting on the left side at A, I'm going to start here with J, because this has to correspond with that J. Then going to the right is B. So that means going to the right is going to be K, and then L, and then M. And so putting these values in now, JM was 9, JK was X. So now I can write my proportion correctly. And I can go 6 is to 9. So 6 is to 9 as 12 is to X. I'm going to cross multiply. I get 6x equals 9 times 12. And I get x equals 9 times 12 divided by 6. And so I'm going to divide 6 into 12. And in doing that, I get 2. And then 9 times 2 is 18, which means that x right up here is equal to 18. If I were to ask you also for the scale factor, remember, you need to compare similar sides. So you can either say 6 is to 9, which is my scale factor, reduce that, divide by 3 is going to be 2 is to 3. Or the same scale factor is going to be, if I compare the top values, 12 is to 18. And that also will reduce by 6, 2 to 3. For this problem, again, this is really important how they wrote the problem. Okay, so that they write it as NOP. See this? This is first. NOP. So that means that I'm going to just redraw another triangle and label it exactly how they did this. They say N, then O is right. So this would be X, and then Y is right. And then Z would be down here. So now I'm going to transfer the values that I have. I've got XZ is 12. I've got YZ, which is W. And so now I'm looking at this and this. And so I'm going to compare the two values, and because they are similar, they told me that. And so I'm going to say 3 is to 12 as 5 is to W. And this value here, this 4, is like a distractor. We're not going to use that because we don't have this value on the top, and nor do we trying to find that. So we're going to go 3 times W, cross multiply, is equal to 12 times 5. I'm going to divide both sides by 3, and I'm going to get W equals 4 times 5, which is 20. So W equals 20. And that's this value right here for that side. Again, GHI, so G, then H, then I. So how they drew this first triangle is how I'm going to draw my next triangle. So this is going to come down, and then this is going to come up like that. And so therefore, I'm going to label it. If I start off right here with G, that's going to correspond with P. So that'll be P. And then now they went down to H. So that means I'm going to go down to Q. And then up to I. So then that's going to be my R. And so now I'm just going to label in my values. I know that PQ is 16. I know PR is N. So now I'm using this triangle here and then this one right here. And if I were to ask you what my scale factor was, you would say 7 over 16 is my scale factor. And then you can't reduce that. That's just it. And if I asked you what's the ratio of perimeters, you'd say 7 is to 16 because those are the same. But I'm asking you what N is. So we're going to go 7 is to 16 as 3 is to N. 7N equals 16 times 3, which is 48. And if I divide both sides by 7, I can't reduce anything. So I get 48 over 7. And that right there is what the letter N is. Given this two similar triangles below, find the value of M. So once again, we're trying to find M, starting off with triangle ABC. So how they drew this triangle is how I'm going to draw my second triangle. I'm not even looking at this right now. So I'm going to draw it just like this, like that. And I'm going to say, well, that was left side A, which means left side X. Then they went B, up B, so that's up Y. And then C came down, so that Z is down here. And now I'm going to erase this because I've actually got to plug in the values of my sides. And so in doing that, I get X, Y is M, and ZX is 11. So now I'm using this triangle, so I'm saying I have to find M. So you're going to go 7 is to M. So you've got to do this corresponding side, right? So 7 is to M as, you're not going to use 6 because there's no side here. So that you're going to use 10 is to 11. So we're going to cross multiply. 10M equals 7 times 11. I'm going to divide by 10. I get M equals 7 times 11 divided by 10, which is 77 over 10, or 7.7, which is the value of M. Now this one right here is a little bit different image, because what you're looking at is this. You know that, we know that right ABC is not at right, is below, is dilated to A prime, B prime, C prime. So if ABC, which is this top triangle here, is dilated, it's got to have this, it's going to be corresponding to the larger triangle, okay, which is this one right here. And so what I would expect that you would do is actually split these up, okay? I would expect you to split the two triangles up so that you can create a proportion. So in doing that, we know that this little side here is 4. We know that this is x. We don't know this length here. But we do know this long side is 10, and this long side is x plus 9. And so when we create this proportion, we're going to go 4 is to 10 as x is to x plus 9. We're going to cross multiply. You get 10x is equal to 4 times x plus 9. And then distribute. So 10x is equal to 4x plus 36. I'm going to subtract 4x. I'm going to get 6x equals 36. And divide by x, I get 6. So I know that this right side here is 6. And I know that this right side here is going to be 6 plus 9, which is 15. Now, if I asked you what the scale factor was, you would tell me 4 is to 10. You could also say 6 is to 15. Either way, when you divide and reduce that, you're going to get 2 over 5. And then that would be my scale factor. That would also be my ratio of perimeters. And at the same time, that would, if I were to ask for the ratio of areas, I would square that and I would get 4 over 25, which would be the ratio of areas. Okay, so the next thing, just to make sure that we covered all of our learning targets and then some, check. Your homework tonight is twofold. You have an exit ticket on Canvas help you in preparation for the quiz that you have on Wednesday. So I do expect you to do that exit ticket by Tuesday night. And then you have a worksheet, which is L 3.1.3 and 3.1.4. It's front back. That's all that is. So wishing you good luck. Thanks for watching. And I definitely hope this helped you. Thanks for watching.